What up, what up? I'm the math teacher Goat, and today we are doing a full lesson on AP Precalculus 2.8 inverse functions. This is a full lesson. Go to the description and download the notes, like and subscribe. Let's get right into it. I like inverse functions. You can't spell inverse functions without fun, and I've never made that joke on my YouTube ever once. Go back and check all my videos and prove me wrong, please. Please go back and watch all my videos. There's like a bunch of them, like 3,000 or something like that. First things first, composites. This is what we dealt with yesterday or in lesson previous. They want us to find, and by they, me want you to find f of g of 1 and g of f of 2. So let's do that guy first. F of g of 1 means I take g of x and replace every x with 1. So g of 1 is going to be 1 squared minus 1, which is 1 minus 1, which is 0. So f of g of 1 would be me saying I now need f of 0. So let's go to f of 0. That's 2 times 0 plus 3, which is 0 plus 3, which is 3. So f of g of 1 is 3. G of f of 2 means let's start out with f of 2. That's supposed to be a 2, as you can clearly see. That's, what is that? You start out with f, replace every x with 2. So that's 4 plus 3, which is 7. And so now I need g of f of 2, which is the same as g of 7. And g of 7 means 7 squared minus 1, which is 49, minus 1, which is 48. Now let's add these two guys together. 3 plus 48 is 51. My age. I'm not 51. Get out of here. If I was, though, I'd look great. So we're going to use our calculator for this one. Okay, graph f of x equals x cubed plus 4. It's a cubic, but I'm not a big fan of what that looks like. So what I'm going to do is I'm going to graph both of these on the same coordinate plane, and then graph y equals x and see what I notice. So again, I'm using Desmos just because Desmos is a little bit prettier. I know we typically use TI-84 pluses, but Desmos is just going to look like a cleaner picture, so that's how I'm going to handle this one. All right, f of x equals x to the third, move to the right, plus 4, like that. G of x is going to equal x squared. No, it doesn't. Parentheses, I'm looking at the wrong thing. Parentheses, x minus 4 to the, and in the to the, we're doing 1 divided by 3. Looks fun. And if I just graph, what, y equals x, which is that perfect line, what do I see? Well, I'm no artist, but it looks like that the green, if I were to tilt my head at a 45-degree angle, these guys are like a reflection of each other. So if you were to take your phone or take your whatever and tilt it so that green was straight up and down, this would be the left and that would be the right, and they're mirror images of each other. So for whatever reason, this function f of x and this function g of x seem to mirror off each other. I wonder why. Let's go back and write it out. What did we learn? Well, what we learned is y equals x reflected f of x and g of x. Now, if you're wondering why, f of x and g of x are inverses of each other. And when you graph inverses of each other, the graphs are going to be mirror reflections over the y equals x axis. Okay, so in this case, we had something that, I forget exactly what it looked like. Didn't it look something like that? And then the other one looked something like, this is gonna be so bad. Oh, I don't even want to do it. Oh, I'm nervous that I'm gonna screw it up, which I know I will. but it didn't look something like that. And so that it acted like as a mirror. The y equals x acted as a mirror, so to speak. Okay, so what we're dealing with is y equals x is very important because y does equal x for inverses. There's a flip-flop and a switcheroo. Let's look at this big paragraph that I had ChatGPT help me create. Okay, basically, and I'm not going to read this whole thing, okay, if you are going to have an inverse, you write it out as f to the negative 1 of x. That means the inverse of x. Basically, what you're doing is you're flip-flopping your y's and your x's. Now, by definition, right, if you have an inverse, there exists exactly one x such that its inverse is going to equal x. Now, what that means is if I were to take f, or if I have f, right, and if it gives me another function, or if I find its inverse, if I find the composite of it, I will get x every time. And if I do the other version of it, I also get x. Okay, so if I were given like f of x equals 3x minus 1, and f inverse, or g of x equals blah, blah, blah. If I find out that f of g of x is x, and g of f of x is x, then those guys are inverses. Okay, so that's thing number one. Thing number two is the word invertible. Okay, now a function is invertible if no two different inputs give the same output. In other words, it's got to pass what's called the horizontal line test. So if I were to take a look at you, I know what you look like. You're going to look like that. So if I were to draw a horizontal line, like so, and pass a horizontal line through that guy right there, you, f of x, are invertible. Okay, so you are invertible. Looking at this guy, though, you're a parabola. So if I were to draw a horizontal line here and try to see if it passes the horizontal line test, it won't, which means you're not invertible. So basically, parabolas, quartics, any even function, they're not going to be invertible. All right, so that's what invertible means. That's a phrase that you're going to see from time to time. Now, how do we find the inverse? Okay, so let's find the inverse for both of these following these instructions, and then we'll deal with 4 and 5, and then we'll leave some space where we can answer 4 and 5 if that's what it takes. Okay? All right, so if I have f of x equals 3x minus 1, step number 1 is you're going to replace f of x with y so that it looks cleaner like that. Then you swap x and y in the equation. So that's going to look like x equals 3y minus 1. You're going to solve for y. All right, so let's add 1 to both sides. Add 1 to both sides, cross you out. X plus 1 equals 3y. Divide everything by 3, divide everything by 3. Let's move the y to the left because it looks prettier that way. So x plus 1 all over 3. And then let's express that y back to its original form as the f inverse of x equals x plus 1 over 3. Now that wasn't too bad. Let's do the same thing over here, but this is going to be a little bit messier. Replace g of x with y, so that equals 2x squared minus 1. Flip-flop the x and the y, so x equals 2y squared minus 1. Add 1 to both sides, so x plus 1 equals 2y squared. Divide everything by 2. So I have x plus 1 over 2 equals y squared. In order to get y all by itself, you're going to square root everything. Don't forget the plus or minus. And so let's flip-flop it around. Y equals plus or minus square root of x plus 1 over 2. And then replace that y with f inverse. So f inverse of x is going to be the positive or negative square root of x plus 1 over 2. So again, invertible is going back to this, because now we have a clear understanding. Basically what invertible means is if I take the inverse, will it still pass the vertical line test? Okay, this one will because that's still linear. This one won't because a positive square root is going to look like u and a negative square root is going to look like u, and you're not going to pass the vertical line test. Okay, now domain and range. This is nice. If the domain is for g of x, ooh, I put f. Whatever the domain is for g of x is going to become the range of its inverse. Whatever the range is for g of x is going to become the domain of its inverse. So if I look at this parabola, I know when I graph that it's going to look like this, and it's going to bottom out at -1. It's going to look like u, and it's going to bottom out at -1. So for g of x, the domain is everything, and the range is everything from -1 upwards. Which, without having to do anything crazy, its inverse is going to be flip-flop that. The domain is now going to be -1 to infinity, and the range is now going to be everything. And again, you can kind of see that as I drew that picture right there. Now, the key thing is, how do I know that the inverse of that is going to look like a sideways parabola? Because the graph of an inverse function is the reflection over the y equals x axis. So if I were to graph the original function, looks like this. Okay, I know that you are going to look like this. Let's move you to the left just a little bit. A little bit. There we are. I know it's not the best picture in the world, but that's because the graph y equals x creates a mirror image of it. Like that. And that's what I was hoping to get. All right, so a lot of information there. A heck of a lot of information there. Let's do a few examples and try to make sure we understand everything. We feel good about everything. All right. Are the following functions invertible? Sketch the graph of the inverse. This is going to be difficult. So, invertible. Let's answer both of those first. Does it pass the horizontal line test? Yes and yes. All right, so if they're invertible, it passes the horizontal line test. Now, in order to graph the inverse, okay, it's a mirror image over the y equals x axis. Boy, oh boy, is that difficult to graph. So what we're going to do is, if y equals x, that means x equals y. What I'm going to do is I'm going to take f of x and find some key points there, like -3, 1. Let me see, -2, 0. Points that I can definitely look at. That looks like 1, -1. 2, -3. Its inverse is going to have you flip-flop the points. So its inverse is going to have points of 1, -3, 0, -2, -1, 1, and -3, 2. That's going to be the inverse. Let me write that better. That's going to be the inverse. All right, so 1, -3, 0, -2, -1, 1, and -3, 2. And I'm going to try to draw that to the best of my ability. And if you look at it, even though my picture's not that great, you should be able to see the mirror image. You should be able to see the mirror image from the left to the right. Like, tilt your head to the side. I could have drawn this picture, this part a little bit better. So maybe more like you. Yeah, drawing is definitely not my expertise, for sure. But we can do the same thing here. Let's pick up some, write out some key points for g of x. So we're looking at -3, -4. Let me see what else. How about -2, -1? How about 1, 0? How about 2, 3? And so its inverse is going to be the flip-flop versions of it. So how about -4, -3, -1, -2, 0, 1, 3, 2. You graph them all, -4, -3, -1, -2, 0, 1, and 3, 2. And so that is going to look like you. This is a much better picture than what I had before. And so with this one, you can clearly see that if I were to draw out the equation y equals x like that, you can see how it splits it. Not perfectly, but splits it well enough. Okay? All right. The domain and the range of a function and its inverse are swapped. I know that. So this is f of x. F of x has a domain of, it looks like, from -2 to +4. So -2 including, +4 including. Its range is going to be from, looks like, -3 all the way up to 1, 2, 3, 4. So -3 to 4. That's the original, which means the inverse is going to have a domain of -3, 4 and a range of -2, 4. So if we look at a couple key points and do the flippy-floppy thing again, -2, -3, its inverse is going to be -3, -2. Here's a good point that we could use. 1, -2 is going to be -2, 1. What else? 2, 0 can be 0, 2. And then 3, 4 can be 4, 3. And so we have this picture right here. I did something wrong. Did I say 4, 3 and do 4, 2? I did. So let's clean that up. My fault, everybody. All right. So what is the minimum value of this inverse here that I just wrote out? Well, the minimum value appears to be -3, -2. Which would make sense because it's, in this case, it's all the way to the left and all the way at the bottom, which means the left side of the domain and the bottom of the range. What's the maximum value? Well, that's going to be all the way to the right and all the way up here, which happens to be the 0.43. So that works out quite nicely. Quite nicely. All right. Use each table below to find the values. All right. This is actually pretty easy. Pretty easy. I mean, regular f of 1 is just, 2. -2, I mean. Regular f of 6 is just 1. Oh, the inverse. Huh. Well, how do I handle the inverse? Just flip-flop them. And I'm not going to write out a table. Remember, you swap the x and the y's. So the f inverse of 1 means you go from the y to your x. So u become u. F inverse of 4 means go to the 4, which reverses back to 5. F of regular 2 is the normal order. So 2 goes to 3. F inverse of 6 means we start out with 6 and go to 3. Same thing's going to happen here. F of 2, go normal. F of 10, go normal. F inverse of 7, go in reverse, which is -1. F inverse of -3, go in reverse, which is 7. F of 7, which is normal, -3. And F inverse of 2, go in reverse, also -3. Isn't that neat? It is. Very neat. All right. The graph of that piecewise function right there is shown in the figure. Let G be the inverse of F. What is the minimum value of G? Well, what we need to do first is we need to see that we have several points here. And really it's going to be one of two, but let's just go crazy and do all of them. -3, 2, -3, 2. So its inverse is going to be 2, -3. We're doing a lot of color switching here. -1, 1. Its inverse is going to be 1, -1. Then over here we've got 1, -2. So its inverse is going to be -2, 1. Very Christmassy, these colors. And then we've got 4, -4. So swapping that is going to be, wrong one, is going to be 4, -4, 4. So we want the minimum value of G, knowing that G is going to be the inverse. G for green. So the minimum value is what I'm assuming what they want is the smallest Y value, which would be -3, which would be -3. So there you have it. There you have it. Mr. Bruce is filling up his backdoor kiddie pool with the water hose. The amount of water in gallons in the pool T minutes after he turns on the water can be modeled by P, an increasing function of time T. Makes sense. Which of the following gives a verbal representation of the function P inverse? Okay, so the amount of water is going to equal, well, let's just say it's linear. So we'll just say like, I don't know, MT plus B. Okay, so your output is how much water you have. Your input is time. Okay, now if this is increasing, like that. Okay, if I were to graph its inverse, chances are it's still going to be increasing. Okay, maybe I should, if this is water in a pool, maybe I should start at 0. Like common sense would say that. So its inverse is still going to be an increasing function. So basically, by doing the inverse, my input is now pool water. So my input is now the pool water. And my output is now time. So let's answer that. P inverse is an increasing function, true, of the amount of time after the water is turned on. Okay. I'm not sure I agree with that. It's not decreasing. It's not decreasing. So P inverse is the increasing function of the amount of water in the pool. So I guess it will go like that. Okay. Oh, I think I understand what they were asking. So it's the amount of water after the time. Okay, that makes sense. Yes. So the output is now the time. I misread that. I don't like that problem. Hopefully it made sense. Hopefully the picture that I drew kind of summed things up nicely. The function f is defined by f of x equals x squared minus 5. Ooh, this is going to be fun, where x is in between -3 and -1. Now, let's do the inverse part first. The inverse part is the nice part. You've got let's call uy equals x squared minus 5. Swap the x and the y, so it's x equals y squared minus 5. Add 5 to both sides, add 5 to both sides, and cross u out. X plus 5 is going to equal y squared. Square root everything. Now, normally, we'll get there. Normally it would be a plus or minus, but we'll explain it. 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 Okay, normally it's plus or minus, boom, boom. So if we make that y equals, we'll just change it to f inverse of x equals positive or negative square root of x plus 5. Now this is where we have to really pay attention to the domain here. All right, in order to determine the correct sign using the original domain, the original function is defined for -3 to -1. For this domain, x is negative. Okay? When we square a negative number, the result is positive. Therefore, when finding the inverse, we must use the negative square root to maintain the correct relationship between x and y. So by doing that, we are only going to deal with the negative version of this. Okay? The negative version of this. So that eliminates u, and that eliminates u. Now, which one is the correct domain, or which one is the correct x values? What we're going to do is now that we have like these numbers, we kind of need to find out the f values when plugged in to get some points. Okay, so f of -3. Like, I have to find out what these are going to be. F of -3 is going to be -3 squared minus 5. So 9 minus 5 is 4. So I have the point -3, positive 4. F of -1 is -1 squared minus 5, which is -4. So I have the point, when I plug in -1, I get 4. This is the range of the original function, which means the domain of the original function, is going to be 4, -3, 4, and -4, -1, -4. So all the action is going to happen between -4 and positive 4, giving us an answer of B. Strange problem. Very strange problem. All right, last page. The function f is defined by f of x equals 3x minus 4 over 2. Which of the following is its inverse? Well, this is just a very straightforward inverse. So change the f of x to a y equals 3x minus 4 over 2. Swap the x and the y, swap the x and the y. So x equals 3y minus 4 over 2. Multiply both sides by 2. Cross out the 2 on the bottom. 2x equals 3y minus 4. Let's add 4 from both sides. Add 4 from both sides. That's 2x plus 4 equals 3y. Let's divide anything by 3. Divide it all by 3. Cross u out. Flippity floppy, y equals 2x plus 4 over 3, which can be written out as f inverse is 2x plus 4 over 3. The answer is U, C. Pretty straightforward. This one, not so much. What are the domain and range of the inverse functions of f? Oh, so, all right. So I'm not finding out what the inverse is. I just want the domain and the range of its inverse. So why don't I just find out the domain and range of this and then swap them? All right, so you need everything inside the square root to be greater than 0 in order for it to work. So x is greater than or equal to 0. So if you add 2, x is greater than or equal to 2, that's my domain. So my domain for f of x is going to be 2 and greater. For the range, it's basically you just need non-negatives. So that's going to be 0 to infinity. That is for regular f of x. Now we want the f inverse, which means just flippity-floppity, baby. So the domain was the old range, so 0 to infinity. And the range is the old domain, so 2 to infinity. So the domain is 0 to infinity, the range is 2 to infinity. See again. And now we get to the weird pre-calculus looking problems, the AP pre-calculus problems. Again, we get all these problems where they seem normal and then they get weird, and that's for the kids who get 5s on the AP exam. That's what this is. So consider the following table of values, functions, f of inverse, and g inverse. So they want us to find out what f is or find out what g is and then find the inverse. So let's do that. So let's find out what f is. Did it say it was linear? No, but this is linear because it goes up by 2 every time. So what we could do is we notice that every time you go up by 1, you go up by 2. So that gives us a slope of 2. So that would be y equals, well, they want f of x. So f of x, and by they I mean me, f of x equals 2x. If we were to just be cute about this and pretend that we were going in reverse and make u a 0, that would make u a 1. Why am I doing that? Because that's the y-intercept. So f of x is 2x plus 1. Boop, boop. Great. Now let's find the inverse. So let's call u y. Let's swap them. In our heads, let's minus 1, so that gives us x minus 1 equals 2y. Let's divide everything by 2. And y is going to equal that. So let's just pretend that's not there. It's sloppy, but who cares? F inverse of x equals that. So A is true, which means C is not. Good old circle all that apply, though. Thanks, circle all that apply. Ooh. All right. Let's do a different color, though. Let's do blue. Okay, let's do the same thing with G. As you go up by 1, you also go up by 2. So G of x is 2x yet again. So, okay, promising. If I were to go backwards, right, and say you go up to 0, that means you go up to 3, so it's going to be 2x plus 3. So we can get rid of u. But I have to make sure the inverse is correct. So let's do the old flippy floppy, y equals 2x plus 3. Swap the x and the y, so x equals 2y plus 3. In our head, let's subtract 3, so x minus 3 equals 2y. Let's divide everything by 2, divide everything by 2. Okay, you're gone, and that's the G inverse is equal to that. X minus 3 over 2. So A and B apply. As usual, please like and subscribe. Make sure you go to my YouTube and type out AP Precalculus 1.8. And that will give you random videos, random AP Precalculus videos for you to watch to help further your understanding and make sure you're understanding everything. So it's just extra for you to do. Extra to do. Thank you guys for watching. Have a wonderful afternoon, morning, night, or none of the above. Bye.